Welcome back. The objective of this video is to determine if matrices are multipliable, I don't even know if that's a word, and to determine new dimensions of a product of matrices. We'll look at some properties of matrix multiplication, and we'll also introduce you to identity matrices. Which matrices can be multiplied? We've got a little explanation down here, so be sure you understand that for the product of two matrices to be defined, the number of columns of the first matrix must equal the number of rows in the second matrix. That is, the middle two indices must be the same. So if we have two matrices A and B, right, we name our matrices rows by columns. So the columns of the first one must equal the rows of the second one. We've got a couple examples here. Might make this a little easier to take a look at. In our sample, we've got matrix A is a 2 by 3 and matrix B is a 3 by 4. Writing that out, we see that we match here in the middle, so that indicates that those two matrices are okay to multiply. Our new matrix is going to be a 2 by 4. So we use the outers to determine what the new matrix is. But if we commute A and B here, B is still a 3 by 4 and A is a 2 by 3. You can see here that the columns of B and the rows of A don't match up, so we can't multiply those. But every once in a while, you'll get ones that are commutative. Here we have P and Q. P is a 4 by 3 and Q is a 3 by 4, so that's okay to multiply, and our new matrix is a 4 by 4. But if we multiply Q by P, they're still okay to multiply, but our new matrix is a 3 by 3. So I said just a moment ago that these were commutative, but actually they're not. They are not commutative because when we flip Q and Q to Q and P, our new matrix, while multipliable, does not equal the original matrix P times Q because it has different dimension. We've got some properties of matrix multiplication here. This may be helpful. Our uppercase A, B, and C are our matrices, and lowercase c is our scalar. And we can run through these properties. Multiplication is associative. That does work. We can multiply B times C first and then multiply by A. That's the same as multiplying A times B first and then multiplying the result by C. It is left distributive. So from the left to the right, we can distribute A in, multiply A times B, and then multiply A times C. Those are going to be equivalent as A times B plus A times C. And same with right distributive. And then the scalar is also associative as well. We can scale A times B. That's the same as scaling A and then multiplying by B. And it's the same as scaling B and multiplying by A. And our final objective here, taking a look at identity matrices. An identity matrix is one in which there are ones on its main diagonal and zeros everywhere else. So only zeros and ones, and the ones are on the main diagonal. So the one on the far left and moving towards the right as you proceed down the rows. Now, identity matrix must be a square matrix. So in an identity matrix, just like our identity property in algebra, the identity matrix times the original matrix will give us the original matrix back as an answer. That doesn't matter what we do. We can multiply A times the identity, or we can multiply the identity times our matrix, and we're still going to get that same answer. The identity is commutative here with multiplication. So there's some more properties on multiplying matrices, and you'll get some more practice with this when I see you in class.